Oh, we'd like to do this double integral. The region of integration is this part of a donut, right? This band right here from radius 2 out to radius 4, and the integral that we're doing is the integral of x plus y. So we'd like the volume under this surface and above this region right here in the xy plane. Now, this is a classic scenario for polar coordinates because the region is a circle or part of a circle or related to circles in some way. And so we will use polar coordinates where we have x equals r cosine theta, y equals r sine theta. Our integral becomes an integral r cosine theta plus r sine theta. That's x plus y. And then the dA, we have r dr d theta. dx dy is r dr d theta. We have that extra r coming in there from the change of variables. The endpoints for r, we have r going from 2 to 4. So 2 to 4 for the endpoints. And for theta, we're going from theta equals 0 to 90 degrees, which is pi halves. So that's the integral in polar coordinates. That is so much nicer to deal with and work with than we would have in rectangular coordinates. This would be a nightmare if we kept it in x and y because this region is not xy friendly at all. But in polar, we have constant endpoints of integration. We have something that we can do. So this is great. Let's go ahead and complete it. This looks like factor it out here, and we have that r, so it's an r squared, which integrates to r cubed over 3 times the cosine of theta plus the sine of theta from r equals 2 to r equals 4. And then we have d theta. And that, let's see, 4 cubed is 64 thirds, and 2 cubed is, we got 8 thirds, so we've got 64 minus 8 is 56 thirds times the integral from 0 to pi halves of cosine theta plus sine theta d theta. And that integral we can do 56 thirds. And the integral of the cosine of theta is the sine of theta, and the integral of sine is a negative cosine. Don't need that integral sign there. I just did the integral. So that is from 0 to pi halves. Plug in those values, and this looks like 56 thirds times the sine of pi halves is 1, the cosine of pi halves is 0, minus the sine of 0 is 0, the cosine of 0 is 1. So 56 times 2 is 112 thirds, and that is the volume that we're looking for, and that's a good example of a double integral done in polar coordinates.